All right, oh, I'm gonna make sure I'm on that pen here. There we go. So, for this video, it's gonna be section 9.5 to 9.7, the review. I have the PDFs already there for you as well, but I'm also gonna talk you through the review and how to do it. So make sure you watch the video. Okay, I think I put that in the directions, but just in case. All right, number one says g of x is equal to 2 tangent of 4x. Okay, and so when you're thinking about the directions say graph one period, describe the transformations. Now remember, some of you are having some struggles with the describe the transformations. You forgot those, so make sure that you get those in there. Okay, so first thing is I'm going to find the period, and the period for a tangent is pi over the absolute value of b. And all that means is just so in case that number is a negative, then it'll always just turn into a positive. So the number that's in the b spot, and I'm going to put it above there again. Remember, it's a, and then it's tangent of bx, and then if we shift it left or right or up or down, any from there. So the number is 4, so it's pi over 4 is my period. Then to find the vertical asymptote, which I'm going to abbreviate as VA, the formula is pi over 2b, or in this case, pi over 2 times 4, which would be pi over 8. Okay, and what that means is that's how far we're going to go to the left and to the right. So if you add those together, 1/8 and 1/8 makes 2/8, which reduces to 1/4. So that's your 1 period's worth. Okay, then we are also going to have a vertical stretch of 2 because there's a number in the a spot, and we are going to have a horizontal shrink of 1/4 because it's, remember, when you do the horizontal stretch or shrink, it has to be the reciprocal of whatever the number was there. So if the number is 4, then it needs to be 1/4, and so on. Okay, so now to go to graph it, this is everything I need for this. Now the only thing I have left is to graph it. I have described the transformations, but I needed those other things to help me out. Okay, so I'm going to make a mark over here at pi over 8, and I just make that whatever big I want. Try to get that same size on the other side if you can. Negative pi over 8, because again, total, that would be, the distance between them would be 1 pi over 4, because it'd be 1/8 plus 1/8, which is 2/8, which reduces down to 1/4. Then to cut this in half, what you're going to do there is you're just going to, if you cut something in half, it's like doing this, you guys. It's taking pi over 8 and timesing it by 1/2, which just means you go top times top and bottom times the bottom. So it ends up being pi over 16. And all you have to do there, multiply the bottom by 2, and then you have a cut in half. That's really all it does. Okay. Now at the pi over 8s, I'm going to make these invisible lines, you know, those asymptotes. Asymptotes are, again, lines that they can't cross, and they're not really there, but they're there to help guide us. Okay, then since the a was 2, this is where we use the a for, I'm going to go up 2 spaces, and I'm going to go down 2 spaces. So your amp was 2. Now, because it's tangent flows uphill. So it's always going to cross here unless we shift it left or right any. And then we're going to go to the right and 1 pi over 16, and then up 2 spaces. And then I'm going to go to the left and down 2 spaces. So it almost makes this straight line right here, but as I'm approaching this, it's just going to take the turn and go up. And as I'm approaching this, it's going to take the turn and go down. And that's what the tangent curve looks like, okay? It's got that straightness in it in between the 3 dots, but then after that, it kind of gradually curves up along the asymptote or curves down along the asymptote at the bottom. And that's number 1. Number 2. We have 3, cotangent 1/2 x. So first of all, to find the period for this, same thing, we're pi over b. B in this case is 1/2. If you ever have a fraction on the bottom of a fraction, you need to multiply it by its reciprocal. And when you do that to the top and the bottom, this cancels out, so you end up with 2 pi. Okay, so that's the period. Also, for cotangent, the vertical asymptote is the same. So the period and the vertical asymptote are the same when it comes to cotangent. Not for tangent, but cotangent it is. We have a vertical stretch of 3, because there was a 3 in the A spot. And we have a horizontal stretch of 2, because there was a 1/2 in the B spot. Then the difference between tangent and cotangent when you come to graph it is the fact that, oops, I want to make it there. I want to make it go over here a little bit. Is I'm going to make it go, oh, that's ugly. How about that one? Oh my God, what am I doing here? There we go, that's a little better. Is I'm going to make it go kind of like our old sine and cosine ones. Okay, I'm going to make it a little bit longer over here. I'm going to go out here at 2 pi, which this part now should be the same as when we did the sine and the cosine. I'm going to cut it in half, which is 1. Cut that in half, which is pi over 2. And then I cut that in half there, which is 3 pi over 2. Okay? Then, with it being an asymptote at 2 pi, the other asymptote is going to be the y-axis, okay? The other one is going to be the y-axis. We're just not going to make a dashed line on top of it because you won't see it anyway. Now, right in the middle, it's going to hit that line unless you shift it up or down any, which I don't think we had too many of them that did that anyway. Then, because it's cotangent, this one flows downhill. And our amp was 3, so 1, 2, 3. I go pi over 2, I go up 3, and 1, 2, 3, down 3. And this is going to ride along the asymptote, take a turn, hit the 3 dots, kind of in a straight line, and then go down the asymptote that way. So this is what a cotangent looks like. It's not around the y-axis, it's moved over. And also it flows downhill. That's kind of the difference between the tangent and the cotangent. Okay? That's number 2. Number 3. I have g of x 1/3 secant 2 pi x. So again, your A and your B. For this one, your period goes back to the 2 pi over b, which is just like the sine and the cosine. And because the reason why is because the secant and cosecant are the reciprocals of those. So, in our problem, this whole thing is b that I circled, not just the 2. The pi comes with it. It's everything from the word secant or cosecant to the x is your b. If you have 2 pi divided by 2 pi, you get the number 1. So your period is 1. Your amp is whatever is in the A spot, and that's going to be 1/3. Then as far as your transformations, you have a vertical shrink of 1/3, and you have a horizontal shrink of 1 over 2 pi. Okay, so then you flip that over, okay? Don't forget to reciprocate that. Now, when you go to draw this one, we're gonna kind of go back to our sine and cosine curves in a sense, where I'm gonna make this go a little bit longer that way. I'm gonna go out here a certain length. Any length will do, but that's my period, so that's 1. And then half of that's a half. Half of that's a 1/4. And then halfway between that, it's 3/4. Okay. Now, as a reminder, secant is the reciprocal of the cosine. Oh, I almost forgot. I gotta make my amp lines. So if I can do this one of two ways. I can go up here and say that this is 1, and then at 1/3, about here, okay, and -1, and about 1/3 is gonna be about there, so that I kind of know where I'm at. Another option would be, if you didn't put those as 1s, you can put them right as 1/3, just to give yourself some more room. Your choice, okay? As long as you label it, it's gonna be okay. But if you don't label it, then we have an issue, all right? So whatever way you wanna go with it, that's your call. I will be okay with it, but make sure you label it. If you don't label it, I'm not gonna know, and therefore I'm gonna mark some stuff wrong. So don't forget to label. Labeling is important with this, okay? So the way I'm gonna do it this time though is, I'm gonna go back to this is 1, and this is -1, and then right about here is about 1/3, and right about there is about 1/3, just so that I know, okay? Then, because it was a reciprocal of cosine, if you recall, and I'm gonna put this in blue, just so that we know, the cosine started at the amp, it hit the line, hit the bottom of the amp, hit the line, and went back to the top of the amp. And it was a U shape. We are not gonna draw that. We don't have to draw that. What I'm gonna do next is, anytime it hit the x-axis, or that middle line, I'm gonna make my vertical asymptotes. So this is going up and down, and this is going up and down. So again, wherever it hit that middle line, so if you shifted it left or right any, that might change it. But if you didn't, then it's that 1/4 and 3/4. Then the other 3 dots, the other 3 blue dots that I have on there, those dots are gonna be where I make my parabolas. And all I'm gonna do is try to make a parabola that approaches both of the sides. So it's just gonna come up in here, and this one's gonna come down, make a parabola shape and go back up. I don't need to add another part of on there. If I wanted to, I could make this 5/4 over there, but not necessary. And then this one's gonna go up here and go up here. Just try to make them so that they're about the same size on both sides, so that you're not getting too big, okay? That's number 3. Number 4. As g of x for cosecant of pi x. So again, I'm going to do the same thing. Period is going to be 2 pi divided by b, which in this case is pi. The pi's cancel, and you're left with just 2. The amp in this case is 4. So that is a vertical stretch of 4, and a horizontal shrink of 1/pi. Because I just flipped that over. Okay? So all those are good. Now, as a reminder, cosecant is the reciprocal of sine. So when I draw this, I'm going to go out here, I'm going to make the period be 2, and then half of that's 1, half of that's a half, halfway between there is 3 halves. I'm going to go up 1, 2, 3, 4. There's my amp line. If I want to make them dashed, I can. 1, 2, 3, 4. There's my other amp line about there. Now, because it's a sine, remember, and I'm going to put the blue dots on here so you can see them. Sine would start here. It would go up and hit the amp, come back down to the middle line, down and hit the amp, come back to the middle line. Where you make your asymptotes is any time it hit that middle line. So you would have one right on top of the y-axis, right at the number 1, and right at the number 2. Those are your vertical asymptotes. Then your parabolas are any time it hit the amp. So this goes there, and that goes that way. So that's number 4. Okay. As far as the graphs go, that's one of each. Then when you get to number, I believe it's 5 and 6. 5 and 6 say find the frequency of the function. Now, just to remind, to find the frequency, it's 1 over the period. Well, what that means in math terms is it's the reciprocal of the period. So if you find the period, you just flip it over. As a reminder, the period for any sine, cosine, cosecant, or secant is 2 pi over b, or the absolute value of b. So for number 5, it says y equals the sine of 2x. So the number that's in the b spot is 2. So 2 pi divided by 2, which is just pi. So there's your period. Now to find the frequency, flip it over. 1 over pi. And done. That's number 5. Number 6 has y equals the cosine of 3x minus 1. The b is the 3, not the negative 1. The negative 1, all that meant, if we were graphing it, would mean we'd shift everything down 1, but that's not important. We're not doing that here. So 2 pi divided by 3. If I can reduce it, I would. I can't, so I leave it alone. So then the frequency, you just flip it over, 3 over 2 pi. And you can have pi in the bottom. It's not a radical, it's not a square root or anything like that, so that's perfectly fine to have it down there. Those are how you do 5 and 6. So hopefully those should be really easy. Just on your note card, don't forget to put, how to find the period and then how to find the frequency. Just maybe put the word reciprocal, boom, and then you're done. Okay? Then the ones for the sinusoid for 7 and 8. See if I can take a picture of those quick off the thing. There we go. Perfect, and it didn't stop my video. I was worried about that. All right, so here's how I do number 7. I'm going to use different colors and whatnot, but one of the things that I'm going to look at is the highest high is at 4. The lowest low is at -2. So that's -2 to 4. So if you think about the distance between them, you're not going to subtract them. You're going to find the distance between them. It's 4 spaces on the top and 2 spaces on the bottom to make 6 total spaces. So to figure out where the amp is, you cut that line in half. Or cut that in half. So 6 divided by 2 is at 3. Or not the amp, I mean the middle line. So that means I can either go 3 up or 3 down. So 1, 2, 3. Or from the bottom, up 1, 2, 3. And it's this line right here, the blue line. Okay? Now, if the blue line happened to be on the x-axis, great, we don't have to do anything. But because it moved everything up 1 space, that means that we are a +1 for that point back there. That's the k, all right? So when you're thinking about this, these are either gonna be sine or cosine. You don't know which one yet. You're gonna have a b, an x, maybe a h, and maybe a k. We did have a k here, okay? Now I'm going to use my red. From this blue middle line, 1, 2, 3 spaces up was how far it went, high it went, or 1, 2, 3 spaces down is how low it went. That's your A. So the 3 is how far from the middle line it is to the top or to the bottom, okay? So that's how we're finding those so far. Then, next, and I'll use, let's use the purple. Now the next thing I'm going to look at is the middle line with respect to the y-axis. If it's hitting the middle line right on the y-axis, that's going to tell us it's a sine curve. If it's hitting the amp for the y-axis, and that's a cosine curve. So this is a sine curve. That's how I know. It also was not shifted left or right any because of the fact that we did not move. That purple dot there is not moved left or right any. So there is no H in this problem. Now, to find the B, what we're going to do is we're going to just count our period. And how I do that, and I'll use black dots for this one, is this is the start, hitting the amp, hitting the line, that's 3, hitting the bottom amp, and hitting there is our 5 numbers. Those are our 5 dots that we normally would make for a sine curve. So if I count, because of the label, that's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So I counted over 4 pi over 4. Now, recall, and I know that reduces, but it doesn't really matter because I have to find B. And in order to do that, I just set it equal to the period formula and I cross multiply. So I get 4 pi times B equals 8 pi. Divide by 4 pi to both sides. And I get 2. So that's the full formula right there. That's of the sinusoid for number 7. Each of those different colors, I did that on purpose so that you could see what I did to get those things. So if you notice, the blue and the red kind of work together. And then the black would be kind of on its own, as well as maybe the purple, just to know if it's a sine or a cosine curve. Okay, so let's do number 8. Same kind of concept. I'll use blue first. The highest high is at, oops, I thought it was blue. Highest high is at +1, lowest low is at -3. The distance between that, 1, 2, 3, 4 spaces. I cut it in half. 4 divided by 2 is 2. So now I either go 2 up or 2 down from the high, 1, 2, and here's my middle line. As straight as I can. Okay. Did that land on the x-axis? No. Where was it? It was down 1 space. So my -1. The other thing that it did, putting them in the same colors, is the fact that I knew that the amp now is 2 from that number. 2. Okay. Now I need to figure out if this is going to be a sine or a cosine. Okay. So looking at the y-axis where it hits it here, and I used the purple last time, so we'll do that again just to stay consistent. If I look at that, that's not hitting there, or sorry, that's not where I wanted it to be. I just actually need to be here. That's not hitting it there. So it's not, now it just depends on which way we're gonna move it. So if you notice, it's not, it's right over here is where it hit that line, or down here it hit the line. So it depends on which way you go. If you want to shift everything to the right, then that would be a sine curve because then that would hit right on the blue line. If you shift everything to the left, that's going to be a cosine curve because it would start at the amp. This is going to be your choice. Depends on which way you want to go with it. Okay? So for this one, if I wanted to stick with the sine, I could. But I moved it over 1 space. Now, how far is 1 space? Look at the labels. This says this line's at pi over 2. So if I want to go half of that, that's pi over 4, which means I went to the right pi over 4. If I chose cosine, and I'm going to put that in a completely different color, I'm going to put it in green. If I would have choose cosine, which is an option, then I would have been plus pi over 4 because I went to the left pi over 4. Either way is acceptable. Those two are the same answers in this case. Then to figure out my B, if I start from here and go highest high low, or middle, I mean, low, and then back up to the line. How far was that? Now, one of the things is with this purple thing here, this is pi over 4. That's how long each spot is. So you can count 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. So I end up with 8 pi over 4 would equal 2 pi over b. Cross multiply. I get 8 pi b equals 8 pi. Divide by 8 pi, and I get b equals 1. So 1x. Do I need to put it if it's a 1? No. But just to show you that it wouldn't matter which way. And again, if you were to put 2 cosine of parentheses 1x plus pi over 4 minus 1, that would also be the same answer. Okay? So that's how you do those sinusoid ones. All right. Moving right along. I do not have a graphing calculator on me, so sorry about that. For number 9, where it says the table in depth shows, so just to walk you through it, the t is your x values. Those you put into list 1. The d is your y values. Now, one of the things about it, and I think some people asked me this earlier, when you look at that, it says t equals 0 representing midnight. So the times where it says midnight, that's really 0. And then 2, 4, 6, 8, 10, and the noon would be 12. Okay, so make sure you put those numbers in there the right way. Then when it says use the sinusoidal regression, after you put those in, you put your stat, you go into edit, you type t into list 1, all the d into list 2, and then you push stat again, but this time go over to calc. Oops, can't spell calc today apparently. And you go down to where it says sine reg, I believe it's what it's called. Okay. And then hit enter. And then or calculate. I don't know, go down right to calculate, and then you just write down what you get. Okay. So that's number 9. I just don't have a calculator to show you the answer there. And number 10. This says the sine of theta is 2/3, 0 to pi over 2. All right, so one of the things that I would do, like on your note card, is make sure you put something like this, where you have, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is back to 2 pi. Those are the radian measures for each of the parts of the quadrants. Now, when you are going from 0 to pi over 2, like this one does, you are in quadrant number 1, which means all are positive. So everything about whatever you are in that one, in that quadrant, or in that zone, every answer is going to be a positive answer. You will not have a negative there. Okay? Now, to fill in the different blanks, you have the sine of theta is equal to 2/3. Don't forget to put in the one I give you, because that would be a shame. You get one wrong for that, and that's a freebie. Also, don't forget, cosecant is just the reciprocal of that. So there's 2 freebies there. Now, to find the rest of them, this is where we have to do some of the stuff that we were doing before I left. And it's the same stuff, it just depends on where we're at. Okay? And what I mean by that is, I'm going to put this in blue. If you remember from that time when we did sine, we put y over the r, and then we put r over the y. Those are the same things for this. And cosine would be x over the r, or r over the x. And tangent would be y over the x, and x over the y. Now, when you're looking at what I give you the y and the r. I just don't give you the x. So in order to find that, it's x squared plus y squared equals r squared. So if I put everything in that I don't know x, I know that the y is 2, and I know that the r is 3. Oops, plus 4, 9, subtract 4 to both sides, I get x squared equals 5, and then I root it, and I get x equals the square root of 5. So it doesn't come out perfectly, but that's okay. And remember, we're not going to put the plus or minus on this because we're dealing with a distance. So let's fill in the rest. Square root of 5 over 3. 3 over the square root of 5. Can't have root 5 on the bottom. So I multiply it by the top and the bottom, and I end up with 3 root 5 over 5. Tangent. 2 over square root of 5. Can't have square root of 5. So I multiply by it, so it ends up being 2 root 5 over 5. Cotangent, flip it. Square root of 5 over 2. I can leave it that way. And that's number 10. Number 11, I'll put on this side so I can use that same graphic there. It gives me the cosine of theta is equal to negative 3/5. And it gives me pi over 2 theta and then pi. So this time, when it says pi over 2 is here, pi is here, so that's everything in this zone, so in this quadrant. If I want to get into quadrant 2, that means my x is going to be negative, but the y is going to be positive. And no matter what, the r, the radius, will always be positive because those diagonal lines are going to be positive regardless, because it's, when you find them, it's squared. So sine I don't have yet. Cosine, oops, I don't want to put cosine. Cosecant. Cosine, well, we got that one. That's negative 3 over 5. Secant, well, might as well find that. That's easy. Just flip it. Negative 5/3. And tangent. Don't have that yet. Cotangent. Don't have all that yet. So, the way this one's going to work is, remember, cosine was x over the r. The r I just said is going to be positive regardless because of the fact that it has to be a distance, a diagonal distance that's going to always be positive. And according to this that I'm circling up in that top left-hand corner, the x is negative, which means this negative goes with the 3. Okay, so the x coordinate is negative 3. So negative 3 is my x. I don't know the y, and I know that the r is 5. Negative 3 squared is 9. Y squared. 5 squared is 25. Subtract it. 25 minus 9 is 16. And the square root of 16 is 4. Now I can fill in the rest of my blanks. So 4 over 5, 5 over 4. 4 over negative 3. I don't care if you put the negative in the bottom. It doesn't matter as long as you have it somewhere. I'm okay. You can either put it in the front or you can put it down with the 3. Doesn't matter to me. And then flip it over, negative 3 over 4. Again, same thing with the negative. You can put it in the front or you can put it with the 3. I don't care. Your choice. Now, just to kind of go back to our graphic here a little bit, I'm going to use purple. If I'm between pi and 3 pi over 2 in zone 3, that would have to be a negative x and a negative y. R is still positive. And changing color here quick. Or not. Let's use yellow then. If I'm from 3 pi to 2 pi, then I'm x is positive, but my y is negative. And that's the difference between all those. Okay? Then number 12. As the tangent of theta equals 4 over, oops, not 4 over 4, good Lord, 4 over 7. It's going from pi to 3 pi, so it's this green one right there, which means my x and my y have to be negative. So when you look at tangent, don't forget that's y divided by x. The reason why it's positive is because two negatives would make a positive if you divide them. So sine, cosecant, cosine, secant, tangent, 4 over 7. Cotangent, 7 over 4. To find the r, 7 squared plus 4 squared equals I don't know squared, or 49, plus 16, 65. And the square root of that is square root of 65. Square root of 65 does not reduce. It's 5 times 13. And those are both prime numbers, so they do not reduce. So that is my radius. And so if you remember, the sine is the y-coordinate, which is just like the tangent, it's the y-coordinate. But remember, it's got to be negative because it was in that zone. So negative 4 over 65. Can't have that square root of 65 down there. So I got negative 4 root 65 over 65. Flip it over, and I end up with root 65 over negative 4. Same thing goes for the other one, for the cosine, negative 7. If I want to just kind of know that it's going to be something like that, I can. And then if I flip it over, I end up with root 65 over negative 7. So that's number 12. On number 13, now I'm asking you to simplify it. What you're trying to do is you're just trying to get it down to as least as possible. Okay, so you have cosine of x times the tangent of x. Now there is no time symbol in between there, it's just understood to be in between. Okay, so what you're going to do is you're going to use those identities that we had in 9-7. It was in both day 1 and day 2. So if you don't have them, you might want to go back and make sure you have those on your note card, because that would be a huge miss if you didn't. And what you're going to try to do is you're going to try to cancel out things as best as you can. Now, cosine, there wasn't one for cosine other than, it's the reciprocal of the secant, which tangent isn't involved in that. But when you look at the tangent ones, you have tangent is equal to 1 over the cotangent, which there's no cotangent here, so we're not going to do that. But it also said that the tangent is the same as the sine over the cosine. And typically what I'm trying to do is I'm trying to get it in terms of sine and cosine so that I can cancel things out. So now to simplify this, what I'm going to do is this cosine, because it's like over 1, would cancel this cosine, because something on the top matches something on the bottom, get rid of it. So then the only thing you're left with is the sine of x. That's what it simplifies down into, and you're done. For number 13. 14 has the sine of x, and then it says cosecant squared of x minus 1. Okay, so when you're looking at that one, the cosecant squared of x minus 1, anytime you see that minus 1 in there or plus 1 in there, those are the Pythagorean ones. And so then what I'm going to do is I'm going to look at the Pythagorean one that has cosecant in it. Well, the one that has cosecant in it, you guys, says 1 plus the cotangent squared equals cosecant squared. Okay, that's the one that I'm going to work with. Now, to get it to look like this that I'm highlighting, I'm going to subtract 1 to both sides. So I end up with the cotangent squared of x equals the cosecant squared of x minus 1. Now this matches what I highlighted. So now, using the power of substitution, I can take that out and just put it as the cotangent squared. So I'm simplifying, I'm reducing it as much as I can. Now, cotangent is the same, remember, as the cosine, but don't forget it's squared, over the sine squared. And what I can do there is I can cancel, because this first one is over 1, I can get rid of one of them, just not both of them. So it just becomes the sine of x and not sine squared. Now, for an end result for this, I have the cosine squared of x over the sine of x, which is okay. Another way that you can look at it is that's the cosine times, cosine over sine. So if you split it, and then cosine over sine is the same as cotangent. So you could also put cosine of x times the cotangent of x. That would be okay, or that would be okay. I will take either way. Okay? That's number 14. On 15, when it asks you to verify it just means that you're going to try, it already gives you the answer. If you just tell me 1 equals 1, that's not good enough. You need to show me the work to make it equal to 1. It's giving you that it equals 1. That's great. But you need to show how it gets to 1. So there's a couple different options here you can do on this one. One option is you could do it like this. This is as simple as this one could be. The tangent of x, the cotangent is 1 over the tangent of x. Oh, not tax. Tangent of x equals 1, so that these cancel to get 1 equals 1. That's option 1. Option 2 is you could have went that this is the sine of x over the cosine of x times the cosine over the sine, and then everything wipes out to give you 1 equals 1. So either way for 15 is a viable option, not a problem either way. Okay? Then I'm going to skip down to do number 17 because 16 got misplaced. It's not supposed to be verify the identity. It's supposed to be in the simplify the expression. No, I'll just do it anyway. When it's got sine squared of theta over the tangent squared of theta, that's not, it's not verifying, it's simplifying it for this one. Okay? So what I'm going to do is the sine I can't do anything about. But the tangent, remember, is equal to the sine squared of theta over the cosine squared. Now to get rid of a fraction inside of a fraction, I multiply by the reciprocal. So this all wipes out. Then if you just zoom in or focus on these two parts, this will be like over 1. This cancels this. So the only thing that you're left with, friends, is the cosine squared. Okay. Okay. And on to the last one. Sine squared of x plus 1 minus the cosine squared of x. Tangent of x times the cosine of x. And we have to show that it's going to equal 2 times the sine of x. Again, you can't just write the thing down and go, oh, it equals 2 sine of x. That is not going to work, and I will not give you full credit for that. You have to show me the steps that you do, so one at a time. So first thing that I'm noticing when I look at that thing is I see that 1 minus thing. That's coming from one of the Pythagorean ones. So I look for the one that has cosine in it. The one that has cosine is sine squared of x plus cosine squared of x equals 1. Well, if I want it to be 1 minus the cosine squared, I just got to subtract it over. So I end up with the sine squared of x equals 1 minus the cosine squared of x. So now I replace this into that spot. So I have the sine squared of x plus the sine squared of x on the top. I have I've not done anything to the bottom as of yet. Okay, just doing it step by step. Then, for the top, this is one of these and one of these. And one make 2 of those. You do not add the squares. You just add 1 plus 1 is 2. Then, if you remember from before, tangent was equal to the sine of x over the cosine of x. So I'm going to replace that now. That's with one of those identities. Now to cancel, I can cancel this cosine with that cosine. That gives me 2, the sine squared of x over the sine of x. And still should equal, remember all this is supposed to equal to the sine of x. That's what we're hoping to get. And I think we're almost there. And I think we might be. Because if you look at the 2, this 2 that I just pointed at with red crayon, that doesn't need to change. But I do have a sine squared in the top and a sine on the bottom. So who has more, the top or the bottom? The top does by 1. So if I take 1 away from both of those, I end up with 2 the sine of x equals 2 the sine of x, which is what I wanted. That's my identity. That is my breakdown. That's how I have to do those. If you don't do them that way, you're going to get stuff marked wrong. So make sure you do. Also, I put a breakdown of the test in Classroom so that you'll know how many questions of each. Watch this video because that way it'll help you. All right, I promise. So on that note, have a good test. Email me if you have any questions. I will see you guys next Tuesday because we fly home on Monday. So far, we won the first game. We're off today, but we played tomorrow and the next. So thanks for all the support, you guys. Miss you guys. And I can't wait to see you guys again. Bye. Or as we say over here, ciao.